Hello students, welcome to this session. Now let us solve problem solving on non-homogeneous system of linear algebraic equations. So in earlier lecture we have seen what is the difference between non-homogeneous and homogeneous system of linear algebraic equations. Now first of all we'll focus on non-homogeneous system of linear algebraic equations, and we are having three options over there. Number one, unique solution we are going to get. Number two, infinite solution, and number three, no solution. So we'll try to check in every case how to proceed with the solution. Now to check it out, we are first focusing on rank of augmented matrix and rank of coefficient matrix, whether they are equal or not. If equal, either unique or infinite solution will be there. If not equal, then no solution will be there. Okay, so let us start with the first problem. Let us read the problem over here. Solve the system if consistent x plus y plus z is equal to 6. First equation. X minus y plus 2z is equal to 5. Second equation. 3x plus y plus z is equal to 8. Third equation. 2x minus 2y plus 3z is equal to 7. Fourth equation. So we are having here four equations in terms of three variables. Now, what we have to do first is we have to convert our given system of equations in terms of this matrix notation, right? So matrix A will be the coefficient matrix. Matrix X will be unknowns. So this will stand out as X comma Y comma Z, a column matrix, and is equal to, this is B. That means coefficients on right hand side, constant values, not coefficients. 6, 5, 8 and 7. Now this coefficient matrix here we already noted. So these are the coefficients from left hand side of each of the equation. So from this equation, coefficient of x is 1, y is 1, z is 1. From second equation, coefficient of x is 1, y is minus 1, z is 2. From third equation, coefficient of x is 3, y is 1, z is 1. From fourth equation, coefficient of x is 2, y is minus 2 and z is 3. Multiplied by your unknown matrix of unknowns, right? And right hand side elements we have combined in column matrix, so that is B. So Ax equal to B. This matrix notation we set up. Now from this matrix only, draft your augmented matrix as A vertical line B. So that matrix is this one. Now when we are applying here the echelon form, what we have to do is we have to focus on all diagonal elements a11, a12, a13 and so on. Jitne bhi hai. Generally we'll try, it's diagonal element a22, a33. So all of these diagonal elements will try to get generally as 1 or non-zero element. And then at each stage we try to get the further elements below that position as 0. So in first step, we'll try to get non-zero element at this position, generally 1, and below elements as 0. In second step, we'll try to get 1 or non-zero member at this position and below members as 0, and so on. So here, let me explain how it goes. Now, already we are having this augmented matrix, and at the position A11, we are having 1. It's a non-zero element, preferably 1 we are having here. Now below elements 1, 3, 2, we are going to get as 0 with the help of these operations involved over here. So this is R2 minus R1, first operation. So second row will get changed and our first row is fixed. So corresponding to this fixed row, the further rows we are changing. So R3 minus 3 times R1, R4 minus 2 times R1 gives us the reduced matrix as, so 1, 1, 1, 6, first row is fixed, second row is converted to 0, minus 2, 1, minus 1, third row converted to 0, minus 2, minus 2, minus 10, and fourth row converted to 0, minus 4, 1, minus 5. So now you can observe A11 position is 0 and below, A11 position is 1 and below that all elements we are having as 0. Now next step will be, here we'll try to get generally as 1 or a non-zero member. Now how to proceed with the next step? Let us check out. Now here we are already having, let me take another color. We are already having here -2, a non-zero element, and observe these two elements जिनको हमें 0 बनाना है. So हम क्या करेंगे यहाँ पर? ये -2 एंड -4 -2 के मल्टीपल के फॉर्म में है. सो हम इन्हें 0 बना सकते हैं आराम से without making this -2 as 1. So let us perform the operation R3 minus 2 times R2, R4 minus 2 times R2. So we are going to get zeros at these two positions and that -2 will be as it is. Now this row we are keeping unaltered and this row we are keeping fixed, and corresponding to this fixed row these two rows we are changing. Okay, now next is A33 position. Now here you can observe at A33 position we are having a non-zero member, right? But this entire row we can divide with the help of -3 so that 1 can be obtained at this position. All right, so or we can divide this row R3 by -3 and we can get 1 at this position, and hence by adding R4 minus 1 by 3 times R3, by performing this operation this member we can get as 0. So there are multiple ways कि यहाँ पर 0 कैसे लाया जाता है. So this position A33 either आप 1 ले सकते हो, either आप -1/3 से डिवाइड करके फिर सब्ट्रैक्ट ऐड कर सकते हो, राइट, या फिर इंटरचेंज करके भी आप ये परफॉर्म कर सकते हो. सो वेज और ऑपरेशंस यू कैन चूज, बट अल्टीमेट rank must be unique one. Rank will not get altered with any series of operations you are performing. All right, now we don't now the entire fourth row is going to get 0, and at A44 positions we don't have non-zero element, it's 0 by operation. So here onwards we don't have any position, so we can end up our operations over here. Now what you have to observe is, you have to observe a step like structure like this. Correct? Now what you are going to count is the number of non-zero rows, and that gives you the rank. So now let me highlight it one more point. This is your coefficient matrix. What is the rank? Number of non-zero rows are 3, and then combine this particular matrix last column over here, and hence this matrix, which is a augmented matrix, its rank is also equal to 3. So row of AB is equal to 3. Both ranks are equal. System is consistent according to our chart, right? And this rank is equal to 3, which is equal to number of variables, and hence according to our chart our system will have unique solution. Now how to find out the solution? Solution find out करने का तरीका हमें मिलता है यहाँ से, इस reduced system से. So from this system I can write down the equations back. So this equations can be obtained from this conversion of augmented matrix to the coefficient matrix or matrix equation what we noted initially. This is xyz is equal to 6 minus 1 minus 9 and 0. Now if we multiply and simplify further, this equation of matrix gives us 3 equations in this way. X plus y plus z is equal to 6, minus 2y plus z is equal to -1, and minus 3z is equal to -9, the way noted here. Now from this third equation you are going to get z is equal to 3, which is this element. Now substitute z equal to 3 in equation 2 here. So this is minus 2y plus 3 is equal to -1. So that will give you minus 2y is equal to -4, hence y equal to 2. Now substitute both of the values of y and z over here. So you will get x is equal to 6 minus y minus z. So 6 minus 2 minus 3, that is 6 minus 5 is equal to 1. So z की value हमें मिलती है 1. So this part we have not included in the chart. Till this point, the chart will help you to draw the conclusion. So this is nothing but the system of linear algebraic equations which is non-homogeneous and have unique solution. Alright. Now in similar fashion, we are having here example 2. I want you to drill this example at your own and verify your answer with this PPT. I will proceed towards the next example, which is of different type. Now this is example 3. Let us check out what type of solution this system will have. Apparently, by just observing the system, we may not get whether it is having any type of solution or not. We need to arrive at the conclusion by using that flowchart, means by finding out rank of coefficient and augmented matrix. Now please check out over here. So this is your first equation, this is second equation, this is third equation, right? And question is similar. Solve the given system of equations if consistent. Now check out carefully here. This equation can be reduced in this way because coefficients are multiple of 2. So हम इसे reduce कर सकते हैं, right? Here also we can reduce the equations in this way. Coefficients are multiple of 3. So now our reduced equations के साथ हमारी system of equations is this one, and in matrix notation we can write down in this way. So coefficients are 2 minus 1 3, 1 1 minus 3 from this equation, and from this equation 5 minus 1 3. X, Y, Z, these are 3 variables, and the right hand side elements are 4 minus 1 and 7. So noted correctly. Now augmented matrix out of these this equation can be noted here, and now what you have to focus is the position A11. A11 position is this one 2, but the below elements are not multiple of 2. So what will prefer to get here 1, and we already have 1 over here. So the easiest operation is perform R12, means R1 is interchanged with R2. So A11 position will have 1. So doing that operation, row 2 and row 1 को हमने interchange कर दिया. So A11 position is now having 1. And now getting 0 at these two positions is quite simple. So further, next operation we can perform is R2 minus twice of R1 and R3 minus 5 times R1. So performing these two operations, keeping row 1 as fixed now, and using this is fixed means what? It's a reference row, right? And with reference row, these two rows you are changing. So below elements are 0, the further elements can be like this. Okay. Now once again, this operation is completed. Now focus on A22. A22 is this position, it's minus 3, and observe the below element, it's multiple of minus 3. So without getting 1 at the position A22, we are performing this operation. So this is R3 minus twice of R2. Here we are going to get 0, and you can observe here the entire row is getting 0. Now how many number of rows are there? 3. And how many number of non-zero rows are there? 2. So rank of augmented matrix is getting 2. What about rank of coefficient matrix? This is also 2. Am I right? So both of these ranks are equal. System is consistent. Rank is equal to 2, and it is less than number of variables, which are 3. And hence system will have unique solution and can be written as by drawing equations from this reduced matrix in further way as x plus y plus minus 3z is equal to minus 1, the first equation. Second equation is minus 3y plus 9z is equal to 6. Now once again focus on this discussion. In last session we discussed about this. Number of equations are 2. and number of variables are 3. So how many number of independent variables are there? 3 minus 2, that is 1. So एक वेरिएबल को हम इंडिपेंडेंट मान के चल सकते हैं. Now out of these two equations, it's easy to pick independent variable from the equation in which less number of variables are present. Means equation 2 से either you can consider z as t or you can consider as y as t. So here assuming z is equal to t, where t is the parameter, right, y you will get as z is equal to t हम assume कर रहे हैं. So this is 6 minus 90, that's right, and minus 3 से हम divide कर रहे हैं, so 3t minus 2, that's right. And both of these values we are putting in equation 1, correct? So y is equal to 3t minus 2 and z is equal to minus 3t. So minus 3t plus 3t will get 0, minus minus plus minus 2, and this is minus 1. So minus 2 right hand side जाके plus 2 हो जाएगा. So x is equal to minus 1 plus 2, it's plus 1, correct? So ये है आपका infinite solution in terms of t, correct? So t equal to 0 के लिए, minus 1 के लिए, plus 1 के लिए, t belongs to actually set of real numbers including 0. So this is our solution. Again, in exactly similar way, problem number 4 you can solve and to cross verify your answer from this PPT. Now I will explain the example number 5, which is again different, but again we cannot predict just by observing the equations. What we have to do is we have to check out the ranks of augmented matrix and of coefficient matrix as well. So the process is similar. Use that chart to get the conclusion and write down your answer. So using these three equations, matrix notation is constructed over here, right? Then construct the augmented matrix as well. Now you can observe here A11 position we are having already 2. The rest of और बिलो मेंबर्स, नॉट रेस्ट ऑफ, बिलो मेंबर्स आर मल्टीपल ऑफ 2 के फॉर्म में है. यहाँ पर तो 0 है तो R3 को हाथ ही नहीं लगाना है. R2 में जो ये वैल्यू है फर्स्ट वैल्यू, उसे हमें 0 बनाना है एंड दिस वैल्यू इज मल्टीपल ऑफ 2. सो द फर्दर ऑपरेशन विल बी R2 माइनस 3 टाइम्स R1, तो यहाँ पे 0 आ जाएगा, करेक्ट? एंड दिस रो इज रेफरेंस रो. इसका यूज करके हमने हमारा ऑपरेशन परफॉर्म किया है. नाउ फोकस ऑन द एलिमेंट A22. यहाँ पर 2 है, बिलो एलिमेंट अगेन मल्टीपल ऑफ 2 के फॉर्म में है. योर ऑपरेशन इज R3 माइनस 3 टाइम्स R2, तो यहाँ पर भी 0 आ गया. अब हमने क्या किया था, इससे रेफरेंस रो यूज किया था, करेक्ट? जैसे जैसे हम आगे प्रोसीड होते जाएंगे हमारे रेफरेंस रो उस वे में चेंज होती जाएगी. एंड नाउ आफ्टर परफॉर्मिंग दिस ऑपरेशन R3 माइनस 3 टाइम्स R2, यहाँ पर 0 आ गया, यहाँ पर ऑलरेडी 0 था, यहाँ पर भी 0 आ गया, बट हियर वी आर हैविंग माइनस 91. एंड बिकॉज ऑफ दिस पोजिशन नाउ यू कैन ऑब्जर्व कोएफिशिएंट मैट्रिक्स is having rank is equal to 2, but augmented matrix because of this element is having rank as 3. Now both ranks are differing, means they are not equal, and hence system is inconsistent. And if system is inconsistent, that means it has no solution. So these are the 3 types of solutions for the non-homogeneous system of linear algebraic equations. Alright, here we are having one more component to study further based on the non-homogeneous system of equations in this way. System of linear equations with unknowns. Now what is happening in this type of equation? Ax equal to b. This is your non-homogeneous system of equations. Then either in matrix A or in matrix B, we are having certain unknowns and unknown constants. So corresponding to values of unknowns, the prediction or the solution pattern of the given system of linear algebraic equations may change. So we have to acknowledge for what values of unknown constants the system will carry a type of solution out of unique solution, infinite solution, and no solution. Alright, the process is similar. Only what we have to observe is the values of unknown constant. Let me give you one example here. Now this is example number 6 in all, but this is the fourth example I'm explaining you. See the question pattern. Investigate for what values of lambda and mu. So lambda and mu की कौन सी values के लिए system of linear algebraic equations x plus y plus z equal to 6, x plus 2y plus 3z is equal to 10, x plus 2y plus lambda z is equal to mu will have no solution, unique solution, and infinite solution. So the system of equations can be written in this way. Ax is equal to b. Again, here we have mentioned our unknown constants at whatever position mentioned over there. Set the augmented matrix in exactly similar way and start operating with the row transformation, that means echelon form. Now position A11 we are already having 1. Below elements can be made 0. Then come to the position A22 and below elements again try to draft as 0, right? And gradually with the help of these operations, whatever unknown constants we are having, that are also going to change. So here we are getting this is lambda minus 1, this is mu minus 6. Further performing R2, R3 minus R2. Here we are getting this is lambda minus 3 and this is mu minus 10. Now here further we cannot change our operations and hence the augmented matrix and its reduction. So here we have to stop. Now let us concentrate on the positions lambda minus 3, this is A33 position, and this is mu minus 10, this is A34 position. Now rank of coefficient matrix is depending on lambda and rank of coefficient augmented matrix is depending on both values lambda and mu. Am I right? So what you have to discuss about? Now case number 1, no solution. Now this particular system will have no solution if row of A means rank of A is not equal to rank of AB. रैंक ऑफ ए एंड रैंक ऑफ ए बी इक्वल टू कब नहीं होंगे? जब ये पर्टिकुलर पोजीशन आपको 0 देगी एंड ये पर्टिकुलर पोजीशंस आपको नॉन जीरो एलिमेंट देगी. सो रैंक ऑफ ऑगमेंटेड मैट्रिक्स must be equal to 3 and rank of coefficient matrix must be equal to 2. So this will happen if and only if lambda minus 3 is equal to 0 and mu minus 10 is not equal to 0. So that gives you the range of lambda and mu, and hence for the value of lambda equal to 3 and mu not equal to 10, system will possess no solution. So what we are doing here, we are just discussing the range of lambda values and mu values for which that pattern of solution will exist. Now come to the case number 2, unique solution. Unique solution is possible if and only if both ranks are equal and equal to number of variables. Means आपकी coefficient matrix की rank भी 3 होनी चाहिए. 3 तभी possible है जब lambda minus 3 is not equal to 0. Correct? And mu minus 10 may or may not be equal to 0 because see this position 0 0 ये अगर आपकी constant position है, I will make it a star here, right? and यहाँ पर 0 है. now coefficient matrix की rank भी आपकी 3 हो जाएगी and augmented matrix की rank भी 3 ही हो जाएगी because of this star position. correct? so what you have, what range of lambda values you are, and mu values you are having here? Lambda minus 3 should not be equal to 0, but mu can take any value. So this is the range. And for this range, system will have unique solution. Right? Come to the next part. Case number 3. Infinite solutions. Now for this system, infinite solutions are possible if and if only if the ranks are equal but less than number of variables. And this is possible if rank of both of the coefficient and augmented matrix is equal to 2 and it is less than 3, and this is possible if the position where that lambda minus 3 is there is also 0 and mu minus 10 is also 0. So for lambda equal to 3 and for mu equal to 10, the system will have infinite solution. So according to the question asked over here, we have to just discuss the cases here, all three cases, and we have to mention for what values of lambda and mu these type of solutions will exist for the given system. And that's it for the solution. In similar fashion, we may have variety of problems like see this example 7. I'll just explain the problem. Find what values of k find the values of k for which the system of simultaneous equations, these three equations are given, is consistent and solve them if this for these values of k. So k की आपको यहाँ पर values find out करनी है जितनी भी है, एंड उन वैल्यूज के लिए आपको इस सिस्टम को सॉल्व भी करना है. So please read out the problems carefully whenever you are solving these problems. Alright. So further we will be continuing in next session the problems based on homogeneous system of linear algebraic equation. I explained a part of it earlier with that chart, but now we'll solve the problems based on homogeneous system of equations. For now we'll stop, we'll continue in the next session.